you what I did. First of all, I put a flat tip screwdriver underneath, and it brought it up some. And then I put tweezers because they're tapered underneath, and it brought it all the way off, like so. But anyway, the second wheel, which has got the cam on it, that this lever here that falls into the count wheel, it needs a bushing also. You can see that it's rocking back and forth, which is, I think you've seen it, but I'm going to point it to you again with the pointer. It's this wheel right here. It's rocking back and forth, so it needs a bushing. And typically, if they need a bushing on one side, they need a bushing on the other side. So we're going to take the intermediate wheel off and the hour pipe, minute pipe, and it's all cleaned. And check out the bushing where, yeah, it needs a bushing also on this side. And this thing is extremely filthy. So I take this thing apart. I would love to have this pinion gear off, but I don't know if it's going to come off that easily. It'd be a lot easier to take the clock apart and put it back together by removing this pinion gear. And normally they're held into place by a tapered pin, but I don't see a tapered pin on this one. And so I'm gonna take it apart without taking that thing off. I'm gonna go ahead and take the bird post off. It would just make things simpler. If I get a screwdriver that will actually work. Anyway, I'm going to take this thing apart off camera and clean it. I got the ultrasonic cleaner heating up. Good thing to note where these levers go also. In this case, this lever, which is the longer lever, goes into the top hole. The shorter lever, which is quite a bit shorter, goes into the bottom hole. Now this is what makes the bird, the bellows, go up and down. High note and low note lift levers. But I got it all apart. I don't want to put this in my ultrasonic cleaner without wiping all this crap off. That way my cleaning solution stays cleaner longer. Much better. Same way with this side. It's got a bunch of junk on it. And yes, I was able to get that pinion gear off the strike side great wheel after I took the movement apart by using my side calipers, side cutters, like I do everything else. There was just enough room once you push up the wheel to get the side cutters underneath, give it a squeeze to lift it up. Off all the gears, and you can see this paper towel is extremely dirty. I would say they probably have animals in their house because there was hair in the gears. This great side great wheel, the time side great wheel, even though it's ratcheting, the click is on top of the teeth. So I'm going to have to fix that also. The strike side, you can, if you look really closely, the click is where it needs to be. And so it's working just fine. But on the time side, this being the click is supposed to go into those teeth, but as you can see, it's on top of the teeth. a corner of it is barely catching the actual teeth, and and that's why it's working. But it shouldn't be that way. So, like I said, I'm gonna have to try to fix that too. I have the temperature set to 35 degrees Celsius. I typically do not put a movement in for longer than 5 minutes, but this doesn't have a protective coating on it. It's extremely filthy. So this is all my ingredients that I use. 50-50 simple green, 50% simple green, 50% water, and then I have Murphy's oil soap, about a half cup, something like that. Quarter cup of acetone. Acetone and the ammonia is what's going to take the protective coating off your movement. So don't use a lot. Then I have Dawn dish detergent. And that's simple green again. But the main ingredients is simple green, water, and Dawn dish detergent. Again, a quarter, maybe an eighth of a cup of acetone, eighth of a cup to a quarter cup of ammonia, about a quarter cup to half a cup of Murphy's oil soap. And I didn't want to put the plastic levers in. This one, which is the longer of the two levers, there's nothing wrong with it. But this lever is broken. As you can see, it's supposed to have a loop on the end, and it's supposed to have these pieces right here that catch the 8-point star wheel to lift it up, and they don't have the loop, and they don't have the pieces right here to catch the 8-point star wheel. And so my dilemma is, how do I go about fixing this? That is the question. I was going to put an eye bolt in it, but the eye bolts I have are too big. So I drilled a hole into the plastic, put this piece here in, and I'm going to glue that in place, and that will be the same thing as what this is. Of course, I'm going to make that loop smaller. And then for these side pieces, I think I'm going to do the same thing. Drill a hole, put a piece of metal in, glue them, and I think that will suffice. Maybe not a piece of wire, but a nail, because it's stronger. Now, the parts are out of the ultrasonic cleaner. However, as I said this many times, an ultrasonic cleaner is like a dishwasher. It doesn't get every nooks and cranny, and that's why you pre-wash your dishes, and sometimes you have to wash your dishes after you use a dishwasher, depending on your dishwasher. But in a case like this, it looks great until you look at the actual pinion gears. Again, this is a pinion gear, and this is a wheel. Wheels match up with pinion gears, such as so. Now, you could take a toothpick and clean out this pinion gear. You could take what's known as pith wood. This wood is mainly for pocket watches. However, as you can see, I got little bitty holes. It costs $3.50 a pack. Part number 15812 from Time Savers. There it is. And you can sit here and push these through the pith wood, pull them out. Again, it's designed for smaller parts. And as you can see, it cleaned it up better. You can also use a wire brush with your Dremel, toothbrush, whatever you got. This is called Rodico, and it costs like $7 or $8, and it lasts forever. It was originally designed for cleaning parts, but I use it to hold parts together when I'm putting movements back together. You can squeeze this around the part, and it will clean out the parts also. You see how dirty that is? My light sucks. Anyway, it's pretty dirty. So I'm going to roll it around this Rodico, and you can see the Rodico is getting dirty. And the part's getting cleaner, but I don't like using my Rodico because I like using it to hold parts together. But it was designed for cleaning parts. So sit here with a toothpick and clean out all the pinion gears. It's got grease and oil and You know, this clock was made back in the 50s. Pop, as I said, Poppo, sorry, they started making novelty clocks in the late 40s, and then they went to making cuckoo clocks in the 50s. This has got a count wheel movement on it. They have count wheel movements. They have regular 25 movements and regular 34 movements in them that they stole from Regula, but it doesn't say regular 25 or regular 34 on it. They just stole the design from Regula. And as you can see with the toothpick, it came out barely clean. I still have to address this click assembly, so I'm going to figure out how to do that next. I'm pretty sure I got to take this bushing off to take these wheels away. Exactly what I did. I grabbed a pair of pliers, pulled this bushing off, pulled this off. Now I can see the click, and the click, it's not pinged down properly. There's a gap between the click and the wheel, so I'm gonna address that with my ball peen hammer. I'm gonna try to ping that pen down more off camera. My video on doing bushings already, so I don't want to get too involved in doing this. I don't want to make this video any longer than what I have to, but I like showing things if it's been a while since I've shown it, because even though I have videos, and you can search for my YouTube channel on bushings, some people just, I don't know, I choose not to search for the videos that I have. And so I like adding bushings into, or whatever, into videos if it's been a while. However you do it, it's totally up to you. I'm going to show you what I learned while watching the VHS tape General Clock Repair by a master clock repair person, Bruce Rasmussen, and you can purchase his DVD on eBay right now. I'll try to leave a link in the description of this video. But in his VHS tape that I watched over and over and over again, he explains it like this. If you have a bushing hole that is perfectly center, no problem. When you start to use your reamer or broach, it's going to find dead center. However, if you have a bushing hole like this that is oblonged, if you start putting a cutting broach or a reamer in, guess what? You're no longer going to get dead center. It's going to go right when you do your bushing. When you put this tool in, your tool is going to hit this spot right here because it's where the dead center of that hole is. However, you're now off from the original dead center hole. So what you have to do, you have to take a small file, and however long the distance is over here, you take a file and you file that distance off of this side over here. That way you find dead center again. I know it's a cruel drawing, but if the drawing was perfect from this section here or from this section here, is going to be the same distance, okay? And that is where dead center normally was, or was before the hole oblonged. So again, if you go to use a drill, cutting broach, or reamer, whatever, in this hole right here without filing the same distance from here as this is, you're no longer going to have the original dead center hole, so your clock is not going to run properly. Again, Bruce Rasmussen, I'm not a clock master, all right? He was, I don't know if he's still alive or not. That's who I learned from. Who do you want to learn from? Somebody who is a clock master, or somebody who thinks they know what they're doing, but they don't? Because I guarantee you there are people out there that are going to have an oblong hole, and they're going to take their reamer and just start cutting away. Well, by natural use of the tool, it's going to find what is now center, but that now center, as I show you, let me do a better drawing. This is center, okay? But in this, if I was to draw that, making an oblong hole, okay, that is no longer center. The center is going to be about right here. Center being equal distance from here to here versus here to here. And so because the tool is automatically going to find the center of that hole. When you put the plates back together, it's no longer going to be where it originally was. And that's why you have to file this side of the hole to make this section the same distance as this section. And again, I suck at drawing, but I hope you get the point. And in this case, this hole right here has got an oblong hole. This hole right here has got an oblong hole. And so you want to have tiny, tiny files. And you can see it better when I flip it over. You see, that's not a circled hole. That's an oblong hole. Same way with that. Same way with that. So you want to file the distance away from the oblong hole with a small file to that way when you put your cutting broach in, your reamer, whatever, it's going to find the original dead center of the hole. I've bought several small files off of Time Savers, and none of them are small enough for these cuckoo clock movements. However, the 10-piece diamond reamer straight, this is the part number, I believe. You can put one of these things into that hole and file it in the opposite direction. I really don't know whether I want to do this on camera or not. You can file it in the opposite direction to get the equal amount of distance. I bought small files, jeweler files off of Time Saver, and they just aren't small enough. I find that the diamond reamer set is small enough, it goes in the cuckoo clock pivot holes. Got the wheels in the plates, so I can know which pivot goes in which hole, and B, so I could do a tilt test. This escapement wheel is tilting way too much, and this second wheel is tilting way too much. This way. Don't tilt that much this way, but it tilts more that way, and that's because the oblong hole goes from this way. It don't go that way, it goes that way. And same way with this escapement wheel. It tilts quite a bit from left to right versus going that way, and that's because the hole is oblong. And so I'm gonna file out these holes, and then I'm gonna get out my micrometer and select some bushings and go from there. Yeah, you want to polish the pivots. You want to feel them to see if there's any burrs, grooves, and if there's not, you take an Arkansas stone. An Arkansas stone is not going to change the diameter of the pivot. Using a popsicle stick with sandpaper, I don't care what the grit is, you will change the diameter of a pivot a little bit. The only thing you're doing is shining it up. If you don't have an Arkansas stone, you can use a block of wood to do the same thing. You notice that I pressed into the wood to get the length of the arbor of the pivot. That way I know I got the wood flat. And I only do the second wheel and the escapement wheel. With the virgin crutch assembly, I'll take my Dremel with the wire brush to it. And sometimes you might have to smooth out the pallets. Like in this case, you can see where the pallet went over the escapement wheel over and over and over again. There's dents in the metal, so you'll want to address that. Also, I have the wire brush on the Dremel, even though there's not that much of a wire brush left on this Dremel. You see how dirty this escapement wheel is? I hold it between my fingers, turn the Dremel on, find the right spot, the wheel will start spinning on your fingers. You see how much better it looks? Now, my fingers are really tough. You might want to wear a pair of gloves. Much better. So bushings, how do you go about selecting a bushing? A, you want to know the height of the thickness of the plate. In this case, it's 1.08, 1.10, something like that. And so you want to try to get the closest to the height and to the diameter of, you want to know the diameter of the pivot. Always zero out your digital caliper. 1.2 is the diameter of the pivot, give or take. You know, some people, when you push the jaws together, some people will close it up really tight and you'll get 1.18, or some people will stop whenever there's some resistance and you're going to get about 1.24, something like that. So depending on how much you use, how forceful you are with the digital calipers is going to depend on your reading. And if you start here, you want to end here. If you start in this part of the jaws, you want to end in that part of the jaws, because especially if you have a cheap digital caliper, the jaws tend to flex. So make sure that you use the same amount of pressure and that you measure the same way every time, is what I'm getting at. Well, these are my KWM bushings, and the height on this bushing is 1.4. The height on this bushing is 1.4, the bore is 1.0, the diameter is 1.8. Okay, the diameter is going to be the overall diameter of the bushing. It's L65. This is a L66, and I'm running out of L65, so I need to order some more. But they all use number 2 KWM reamer. So with the reamer set, it's tapered. This is my reamer set. This is 1, 2, 3, 4, and 5. And I'm going to show you, this is the biggest reamer I have. You see how it's tapered? It starts off small, and then it tapers, and then the final cut is up here on this flat end. That's the way they all work. With cutting broaches, you have to start with a small one. They're all tapered, but you got to start with a small one, and then go to the next one, then go to the next one. With cutting broaches, you want to broach both sides of the plate. With the reamer, you start off and then you continue, because when you're done with this reamer, you're going to be using the flat section of the reamer. With a cutting broach, the reason why you mark off your broach, and then you use this, you go in from this side until your mark and then you go in from this side into your mark. Because they're tapered, if you don't do that, you can't put a square peg into a round hole, basically. That way, it's because they're tapered. It because you go in both sides, it basically makes the hole the same way as this end process does. But you have to go in from both sides. With the reamer, you start on one side and you finish. I got the original box for these bushings around here somewhere. The only difference between L65 and L64 is the the bore diameter. The height is 1.4 millimeters tall. The diameter of the bushings is 1.8 millimeters tall, but the bore diameter, that's the only difference. With the L65, it's 1. With the L64, it's 1.1. And so I'm going to use, it doesn't matter, I'm going to use either one. But because I told you the pivot diameter on these bushings is 1.21, I'm going to have to use a cutting broach to bore out the hole. And it's best to bore out the hole before you put the bushing in the plate, because when you put the bushing in the plate, you only got like 0.1 millimeters, 0.2 millimeters that you didn't cut off. And so if you use a cutting broach and you start broaching out the bushing after you put it in the plate, it's a very good chance that that bushing could spin in the plate. So it's best to broach out the hole before you put the bushing in the plate. And so I selected a bushing. I put it on the end of a toothpick, and then I put it into my drill, and then I closed up the jaws. And then I selected a cutting broach, and I stuck it into that bushing, and then I turned on my drill, and I broached out the hole. As you can see, it passes the tilt test. It fits in, but I still have to ream out the holes on the plates. And so again, the bushing that I selected uses, per my diagram, uses a KW a number 2 reamer, which it should be this reamer right here. And I told you that the diameter of the bushings are 1.8 millimeters in diameter. And so putting my digital calipers on the end of this reamer, you can see it's 1.77 millimeters 1.77 millimeters in diameter. So there's not that much play, is what I'm getting at. And so getting out the tool for this number 2, you put it in, and then you start turning. And it doesn't matter whether you put it in from the front or from the rear, it doesn't matter. And once you go in, you want to stop. You don't want to turn it anymore. And now I want to put that bushing, that very small bushing that's in my drill, in the hole that I just reamed out. Before you put the bushing in, you want to take what's called a chamfering bit and just barely catch a couple of turns, and that takes away any burrs that you created during the reaming or broaching process. Now, this is the hole that I reamed out. This is the bushing. I choose to put them from the rear plate to the inside plate to the outside plate. And working with really small stuff, if it would fit in my watchmaker staking set, I would be using that, but it doesn't. You want to make sure it's flat. If it's not flat, if there's a burr, it's going to stop your plate. And when you put the bushing in, you might have to broach out the hole again, because you're taking a piece of brass and you're putting it in. It's going to make that hole smaller, so you might have to broach it out. And you want to use a smooth cutting broach when you're done, and the smooth cutting broach will take away any burrs. One down, several to go. And when you get them all done, you're going to put them in the plates, and that way you can see whether or not they've got end shake and that they all fit properly. Now, I don't have the other one for this second wheel done yet, but I'm just going to show you what you do after you get all your bushings in. You would check to make sure it spins properly. Now, I'm not worried about it at this time because the other hole is oblong. And then you would make sure that you have proper end shake, rear plate to front plate shake. But as you can see, it spins properly. It's several rotations. But I have several others to do, so we'll come back after I get those done. The smooth cutting broaches for the set that I bought, they're not really made for cuckoo clocks. So that's where the diamond reamer comes into play. Because after you got your bushings in, if you don't have end shake and if the holes are not smooth, you won't be able to get it to do this. And that's what you want. You want it to be able to spin several revolutions. And it has end shake. And so, like I said, you test each one at a time, but you have to know which way they go in. And so stupid wire over here is being a nuisance. You notice it doesn't spin that well? There is inch shake. There it's spin better. But I'm going to take that diamond reamer to both of the holes just a little bit. You know, it's a reamer. And you will also notice that I took my grinder to make sure that these were smooth. If they're not smooth, then it's going to create issues. Now, I'm doing this all by hand. if you're doing this for a living, you might want to invest in a KWM or a Bergeron bushing machine, which makes things so much faster. But I don't do this for a living. I don't want to spend $1,000 on a KWM bushing machine. Even a used set is quite expensive. And so that's why I'm doing what I'm doing. I'm not for sure if I got that second wheel, the escapement wheel in the right position. That's not even the escapement wheel, it's the second wheel. Second wheel goes here, escapement wheel goes this way. So if you don't test all this stuff, your clock will not run, period, after you put bushings in. So yeah, it's a pain in the butt, and yeah, that's why clock repair people charge what they charge. So now it moves freely, and we have in shake. In shake again is front plate to rear plate. So the time side is done. Now I have to work on the strike side, and I told you the only one that's on the strike side that I need to worry about is the second wheel. Putting the movement back together, I didn't take pictures. Pictures are your friend, and I stress that all the time. Um, it's been a while since I played around with this movement, and I'm concerned about where this spring here goes. That spring is to put this lever here into the count wheel. However, as you can see, I got Rodico, everything. I have a Poppo cuckoo clock that has the exact same movement in it, and I need to pick something on this anyway, so that's one of the reasons I didn't take pictures, because I've got a movement that's exactly like this. Now, this particular clock takes 640 grams of weight, so these are the original weights that came with it, and so when she picked up the clock from whoever had it, they gave her the wrong size weights. They gave her 275 gram weights. But because this is a count wheel movement, anyway, I'm going to take this movement out just so I can look at where that spring goes. And like I said, there's an issue with this clock that I need to fix. And so I got to take it apart anyway. So it's no big deal. And what is better than pictures? The actual thing itself. This spring that I was wondering about, it goes on the underside of this lever that goes into the cam, that goes into the count wheel. There's a spring right here. And it doesn't go in that hole. That hole is for the wire that you, if your cuckoo's off, you push on that wire, and it allows your cuckoo to catch up. Now, this is my bird. It's wooden bird. It doesn't have articulated wings like a lot of the Poppo cuckoo clocks have. Where her bird is a plastic bird. Big difference in size also. But anyway, now I know what to do to put her movement back together. So I got the movement back together, and I don't have a count wheel on or all the other parts on the front on, but I just want to do a test. And as you can see, the lever, the brass lever here that goes into the cam is going into the cam, and that's because the mouth of the Pac-Man is at the 12 and 3 o'clock position. And then the third wheel with warning pin, which is this pin right here, is hitting the end of the brass lever that goes into that cam. And I like using a lot of force when I'm testing the movement. If that force if I'm using a lot of force, when you put the weights on, which is not going to be as much force as me doing it, is going to work properly. So now all I have to do is put the front, everything back on. I also have to clean up my Rodico off the wheels, and that's all it takes is putting the Rodico on the wheel and pulling it off. Um, but I use Rodico to help put the movement together. So I want to go through and make sure I got all the Rodico off. But we are getting there. So I had to clean off my entire desk, and I rearranged some tools, drilled some holes on this clock stand to put some tools in. But I've had these parts in this box the entire time I've been working on this clock, and not that clock, this clock. And I go to put the intermediate wheel on, and it's not in this box. Count wheel is, hour pipe is, all the other parts are in here. The compression washer, intermediate wheel is not in this box. Where the heck is that? I have no idea. I know people think I'm full of crap when I tell them that there are little spirit kids that are in my house that like playing games. This box has kept all these parts for the past several days, and I go to finish the clock and the parts are not in there. Well, luckily I have a spare movement, and I'm sure this intermediate wheel here will fit on there. The plastic wheels that are for the regular 25, regular 34s, they do not fit. Well, I take that back. Let me get one out. They fit on here, okay, but, and as you can see, it's turning it, but this is not off a regular, this is not off a regular 25 movement. I had one, let me get it out. That's off of, I think that's off of a AMC movement. Sorry, an AMS movement. Anyway, luckily I have spare parts, but it just really ticks a person off that, here's the wheel, that you put stuff in a place and when you go to need it, it's not there. As you can see, the teeth are just they're just a little bit longer. The shaft is too small, and so anyway, I have spare parts. And the high note and low note lift arms, they're plastic, and I thought I was going to be able to modify them to get them to work, but the AMS movements count wheel is the same style. This is an AMS high note lever and low note lever. I think I can get it to work, but I'm going to have to drill these holes to make them bigger. That's the problem with Poppo cuckoo clocks. If it's a regular 25 style movement or a regular 34 style movement, parts are readily available. But for the count wheel type movements, parts aren't readily available. This movement, the count wheel movement, it's got a different style 8-point star wheel in it. As you can see, it's got little tabs bent over. So the arms are just pins versus a flat piece of metal, and they don't fit in the holes either. So either way, I'm going to have to drill out the holes. So unfortunately, my spare movement intermediate wheel is too dang big. So I took a intermediate wheel off a regular 25, put it in my drill, sanded it down, and then I took a file and I cut out all these teeth. They were already there, I just made them deeper. And so it works. As you can see, it's turning the wheel. And now the hour pipe doesn't match up, so I'm going to have to do the same thing to the top pinion gear. Only because the stupid intermediate wheel is not in the stupid box where it's supposed to be. Welcome to my world and my house. So I put a pair of pliers in my ultrasonic cleaner and I forgot about it. And I went to get them out. And guess what? I found the wheel. So thank God that I don't have to mess with that stupid thing anymore. And there are still spirits in my house, by the way. But anyway, thank God I got the wheel and can continue putting the rest of this together. When you put the cuckoo bird back on, you have to play with it a little bit. You loosen up these screws and you push the bird out. If this lever is in the wrong spot, it will not work as well. So you gotta kind of play with it as you tighten up this lever. You see that? It's not going back in the right spot. And I had the spring wrapped around this top screw versus tying it in a knot. You just gotta find the sweet spot where the bird needs to go. As you can see, it's going back where it needs to go. I think I found the sweet spot. And it's not going to come all the way out. It's hitting this post right here. It's only going to come out however long this wire is that opens the door. And I like tilting it a little bit to see if it's going to go back in. As it's tilted, let's see if I'm happy with it. If I'm not happy with it, I'm going to make that spring tighter. You see what I did? I put a kink in the spring, and now the bird goes back really quickly, and that's what I like. And doing a function test, I'm going to turn this wheel right here. And at the same time, I'm going to put some pressure on the grate wheel. For the cuckoo side. I gotta, because I want to see if this wire is going to activate the cuckoo. There you can see the lever coming out of the count wheel. And it's cuckooing. And that had been 12. This is going to be the half hour, 12:30. That's 12:30. This great big slot is from 12, 12:30, 1, and 1:30. 2 is this burst black piece here. 2 and 2:30 is that spot right there. But this from here to here is from 12 to 1:30. Just like with all countwell clocks, cuckoo clocks. That was 1, 1:30, 1, 2. I lied to you. This one's a little bit different. It's got this piece right here, and that's for the 2 o'clock. So this would be 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So this little piece right here is for the 2 o'clock. And it missed the 2 o'clock, so I'm going to have to go all the way back around because it went from 2 to 2:30. It didn't stop on the 2:30 mark. So I'm going to have to go all the way back around and fix that. This Poppo cuckoo clock movement has never been as good as it is now. And the reason why I say that because this low note and high note bellow lift wire is from an AMS movement, and metal versus plastic. The plastic ones were broken, so I drilled holes in here to because these are thicker in diameter, bigger in diameter than plastic ones, and then I had to drill a hole in here. E-clip holds the lever on, but then the 8-point star wheel doesn't match up because it sits, if I can turn this thing back around, it sits lower than the paddle that catches the 8-point star wheel. So what I ended up doing was, and I haven't done it to all the teeth, I end up bending these teeth up in the air some, but if you bend them too much, it's going to hit the cam that's on the second wheel. So you only bend it so far, and so as the wheel turns, the lever comes up in the air, and it works. I got that last one because there's end shake in this wheel. I got that last one bent just a little bit too far up in the air, so I need to bend it down some because it's hitting the cam on the second wheel. And so again, I don't have them all bent, and so when I get to a bent one, it's gonna lift it up like so. Like so. And I got the thing held down, so see it lifts it up higher to give the bellow what it needs to do. So anyway, we're getting there. I just want to point out that with regular movements, there's a U wire and a V wire, but not in this case. the pendulum leader wire is round, and so I never did look at it underneath my microscope, but if the clock doesn't stay running, the first thing I'm going to do is to add a V wire to this U wire, because if there's flat spots, the clock will not stay running. Time for me to take a break. So due to intake, the levers, the 8-point star wheel kept hitting the cam. So what I did was I bent these arms down some. And so now it works. I don't have the clip on, and that's why it's not coming back down all the time. And once you connect the bellow up, it's going to come down like it's supposed to. And it's hitting this wheel here. So anyway, we're getting there. And remember, the high note lever goes up on top for this particular clock.